Okay, now we discuss about the simple harmonic oscillator and also we derive the equation of periodic time. Now, after that, and also we derive the differential equation for pure simple harmonic motion and damped oscillation. What is the damped oscillation? The oscillation of a system in which the amplitude of the system or the amplitude of oscillation decreases with time. Such oscillations are known as the damped oscillation. The oscillation in which the amplitude of oscillation decreases with time, such oscillations are known as the damped oscillation. Why the amplitude of oscillation is going to decrease like this way? Suppose there is a pendulum. Pendulum is, there is the equilibrium position. As it is placed and released, so it performs the oscillation. So for first oscillation, amplitude is this. Next oscillation, the amplitude is quite less, like this. So at last, its amplitude is decreases and then stop. So there is the amplitude decreases with time. So such oscillations are known as the damped oscillation. Because here the resistive force by the medium act on the oscillating body. Therefore, the amplitude of oscillation continuously decreases with time. Therefore, such oscillations are known as damped oscillation. We also derive the differential equation for damped oscillation. Okay. Here the amplitude is continuously decreases. To sustain the oscillation, or the amplitude of oscillation, here the continuously periodic force is required. Continuously periodic force is required. And therefore, the oscillation in presence of external periodic force are known as the forced oscillation. Again, due to the resistive force of a medium, the amplitude of oscillation decreases with time. Such oscillations are known as the damped oscillation. To sustain the amplitude or the oscillation of a body or the system, the external periodic force is required. After applying the external periodic force, the oscillation in presence of external periodic force are known as forced oscillation. Clear? Okay. Today we are going to discuss about the forced oscillation and also we are interested to derive the differential equation for forced oscillation. Before it, first we discuss about the natural oscillation. Natural oscillation, that means the oscillation of a system in absence of any resistive force are known as natural oscillation. The definition of natural oscillation is that the oscillation of a system in absence of any resistive force is known as natural oscillation. For natural oscillation, angular frequency and frequency of oscillation are omega 0 and f 0. So in short, there is the ideal oscillation in absence of any additive force. So such oscillations are known as the natural oscillation. Now next is, what is the free oscillation? What is the free oscillation? When a system is displaced from its equilibrium position and released, it oscillates with the natural frequency. Such oscillations are known as the free oscillation. When a system is displaced from its equilibrium position and released, it oscillates with natural frequency. Such oscillation are known as free oscillation. Angular frequency and frequency of frequency of free oscillations is omega and f. That means the angular frequency is denoted by omega and frequency of free oscillation is denoted by f. Clear this? So these are the two definitions of, one is the definition of natural oscillation. Natural oscillation, that means the oscillation of a system in absence of any additive force. The angular frequency of natural oscillation is denoted by omega 0 and frequency of natural oscillation is denoted by f0. Now what is the free oscillation? When a system is displaced from its equilibrium position and released it, so it oscillates with the natural frequency, and such oscillations are known as the free oscillation. Now any system, in the beginning, the oscillations start with the natural frequency. So initial stage, it oscillates with the free oscillation. The angular frequency and frequency of free oscillations is omega and f, denoted by omega and f. Now after that, the next question is that define the forced oscillation. And obtain differential equation for forced oscillation. So we have the experience in presence of the air medium, if the system is oscillate, so its amplitude is continuously decreases with time due to the resistive force applied by the air medium. To sustain the amplitude of oscillation, the periodic force is required. Therefore, to sustain the amplitude of oscillation, the periodic force is required. And such oscillation in presence of external periodic force are known as the forced oscillation. The oscillation of a system in presence of or in the oscillation of a system under the influence of external periodic force are known as force oscillation. Right? The oscillation of a system under the influence of external periodic force are known as the force oscillation. The amplitude of oscillation decreases with time due to resistive force of a medium. To sustain the oscillation of a system, an external periodic force is required, and external periodic force is required. The external periodic force is Fd is equal to F0 cos omega d into F0 is amplitude of external periodic force, and omega d is angular frequency of external periodic force. It also the angular frequency of force oscillation So there is the information about the force oscillation, but in our question only the definition is required, so you have to write down this. Now what is the force oscillation? The oscillation of a system under the influence of external periodic force are known as the force oscillations. The amplitude of oscillation decreases with time due to the resistive force of a medium. To sustain the oscillation of a system, an external periodic force is required, and the external periodic force is denoted by Fd is equal to F0 cos omega d into d. Right? F0 is the amplitude of the external periodic force, and omega d is the angular frequency of external periodic force. And this angular frequency is also known as the angular frequency of force oscillation. We have the experience last we discussed, as you sit in a swing. So initially the swing is start the oscillation. But in short time, so amplitude of oscillation is decreases and last then going to stop. To sustain the oscillation, we have to apply the force on a swing by our leg. So we apply the force like this way. So again the swing start to oscillate. And this force is applied at each and every some interval of time. Therefore that is known as the external periodic force. So what are the oscillation of a swing due to the external force applied by our leg? So this type of the oscillation are known as the force oscillation. Now we are going to derive the equation, differential equation for forced oscillation. Now we are going to derive the differential equation of forced oscillation. So first we have to mention how many forces act on a system perform the forced oscillation. Therefore, when a system performing a forced oscillation, the forces act on it are, or in other words, the forces act on when a system performs a forced oscillation are first the resistive force, first is the force F is equal to minus Kx. There is the restoring force. Restoring force Fs is equal to minus Kx. Second, the resistive force, that is the Fd, is equal to minus B. And third, the external periodic force, external periodic force, Fd, is equal to F0 cos omega d into T. Therefore, total force act on a system is Ft is equal to Fs plus Fb plus Fd. Substitute the value Fs minus Kx. Now Fb minus Bb plus F0 cos omega d into T. That is our equation number 1. But from Newton's second law, resultant force Ft is equal to in equation 2. Therefore, combine equation 1 and 2. Comparing equation 1 and 2, we obtain Ma is equal to minus Kx minus Bv plus F0 cos omega d into T. Omega d into. Now substitute acceleration as double derivative of displacement d square upon dt square, and velocity v is equal to dx by dt. Therefore, m into d square x upon dt square is equal to minus k minus b dx by dt plus f0 cos omega d into t. Take this term, negative term on left hand side. Therefore, m into d square x upon dt square plus b dx by dt plus kx is equal to f0 cos omega d into t. Omega d into t. Dividing by m on both sides. Therefore, d square x upon dt square plus b upon m dx by dt plus k upon m x is equal to f0 upon m cos omega d into t. Is the differential equation for force oscillation. Here, to derive the equation, the method is same. Already we derived the differential equation for pure simple harmonic motion and also damped oscillation. First, we mentioned how many forces actually, and the addition of these forces that gives the total force act on an oscillating body. Compare this equation of total force with Newton's second law, F is equal to m, and substitute A is equal to d square upon dt square and B is equal to dx by dt. And rearrange the term, we obtain the differential equation. Again, what is the force oscillation? The oscillation of a system under the influence of the external periodic force is known as the forced oscillation. The forces act on a system perform a forced oscillations are: first, the strain force Fs is equal to minus kx. Second is the resistive force due to the medium Fb is equal to minus b. And third is the external periodic force. External periodic force F is equal to F0 cos omega d into t. Therefore, the total force act on a system is Ft is equal to addition of these three forces, Fs plus Fd plus Fb. Clear? Therefore, Ft is equal to minus kx minus Fd, that means the Bv, plus F0 cos omega d into t. Now from Newton's second law, the resultant force Ft is equal to Ma. Comparing equation 1 and 2, Ma is equal to minus kx minus Bv plus F0 cos omega d into t. Now substitute A as d square x upon dt square and B is equal to dx by dt. Therefore, we obtain m into d square x upon dt square is equal to minus kx minus b into, instead of the v, here dx by dt plus f0 cos omega d into. Take this negative 2 term on left hand side, therefore m into d square x upon dt square plus b dx by dt plus kx is equal to f0 cos omega d into t is the constant force. Dividing by m on both sides, so we obtain d square x upon dt square plus dy m into dx by dt plus km into x is equal to f0m into cos omega d into t is the differential equation for forced oscillation. Now, amplitude of a system during the forced oscillation, the amplitude of system during forced oscillation is A is equal to F0 upon into bracket m square omega square minus omega d square whole square plus omega d square into b square whole is to half. Whole bracket is to half. There is the amplitude of the system from the forced oscillation. A is equal to F0. F0 is the amplitude of external periodic force. Omega is the angular frequency of the natural or the pre-oscillation, natural angular frequency. Omega d is the angular frequency of applied external periodic force. B is the damping coefficient. B is damping coefficient. Initially, the system starts the oscillation with natural frequency. When the external periodic force is applied on a system, so what's happened? The natural frequency or the natural oscillations are died, and the system starts the oscillation with the periodic external force with frequency omega d. Initially, system oscillate with natural frequency. When external periodic force is applied, natural oscillations are died, and system oscillate with frequency of external periodic force. External periodic force. So in short, any system initially starts the oscillation with the natural frequency. That means the natural oscillation is started. When we apply the external periodic force, what's happened? Natural oscillations are stopped, and what's happened? The system oscillates with the frequency of applied external periodic force. So there is the differential equation of the forced oscillation. Right? On the basis of this, we have to discuss about the resonance. We discuss after the simple pendulum. We have done the equation of the amplitude of the forced oscillation and explain the resonance. Right? We discussed last.